Welcome to Out of This World. I'm Matthew Nicolantonio, joined by meteorologist and science writer Scott Sutherland. Scott, today we are talking about bits of dust and ice and rock that orbit the sun and travel through our solar system. We are talking about comets, meteors, asteroids. A lot of people probably think these are all the same thing.
Right.
They're close.
Oh, yeah.
But there are differences. So we're going to sort of work through what each are, sort of some famous ones, and is there a threat to Earth from these bits of matter floating through our solar system? So let's start with asteroids. Okay. What is an asteroid?
So an asteroid is a giant, basically either a giant rock or a bunch of rocks all sort of clumped together that are floating around in space. Okay. So it's mostly rock. Like we're talking similar to like Bennu that OSIRIS-REx went to, or Didymos and Dimorphos that the DART mission went to. These are mostly, well, they'll have ice mixed in there, but it's mostly what we would think of as like boulders and dust and rock.
Space rocks.
Yeah, space rocks.
All right.
Yeah.
Now let's move on to meteors, meteorites. How are those different from asteroids?
Okay, so a small asteroid is known as a meteoroid. So anything less than about a meter in size, we call a meteoroid. Okay. And that is just, again, another piece of rock or dust flying around in space. When it hits our atmosphere, it produces a meteor, which is the flash of light that we see as that kind of that piece of dust or rock sort of slams into the atmosphere. And it pushes the air in front of it so tightly and crushes that air together so tightly that it heats it up, and so it produces that incandescent flash, and that will either slow that piece of rock down enough that it can't push anymore and it goes out, or it'll vaporize that piece of rock, so then the meteor vanishes. And if anything from that journey survives, it becomes a meteorite, which we can then find on the surface.
All right.
Yeah.
All right. Last one, comets.
Right. So a comet is sort of take that rocky asteroid, surround it with several kilometers of ice, and then you have a comet. These ones, there are many of them. There's the Oort cloud out. Wait, this is maybe halfway between us and the nearest star system. This giant, they call it the cloud, the Oort cloud. These are all comets, these giant icy bodies that sort of loosely orbit around the sun. But what we know as comets are ones that come into the inner solar system, fly around the sun. They produce a long tail that we can see, two tails for that matter, and hopefully show up brightly in our sky that we can see them. There have been some that have fizzled, but there are some famous ones that really capture our attention every time they come back around.
Let's talk about those. The most famous one that people probably know, Halley's Comet. Origin story. Where did that come from? Why are we able to see it so clearly? And is it something that we can still see?
Right. Now Halley's Comet, as far as the origin goes, it probably was just some object that was out beyond Jupiter, got a little nudge from gravity between Saturn and Jupiter and started its journey around the sun. How long ago that was? I think we have records of Halley's Comet going back to the 1500s, longer, like that, back into BCE times. So it's been going around Earth a long time. It goes around the sun every 75 years. Currently, I believe it's out beyond the orbit of Uranus or Neptune, and it's working its way back in towards us. It was last around here 1993 or 1986. I can't remember the exact date of that. But it comes around once every 75 years, so it's going to be a little while before we see it again.
Right.
We get 2 yearly reminders of its presence, though. Okay. Because Earth flies through the trail of dust and ice it leaves behind twice every year. Okay. It produces 2 meteor showers. The first one is the Eta Aquariids, which is in May. And the second one is the Orionids in October. Okay. So basically it's as those little bits come in going one direction, we fly through it. And then when they're going the other direction away from the sun, we fly through it again. So we get 2 reminders every year of the presence of this comet. And then once every 75 years, we get the actual comet coming around.
Right, and we get to see it.
Right.
Are those the sort of the most famous meteor showers that we get to see here on Earth? I know you said there are others.
Oh yeah.
Where I guess maybe where do they rank among the most impressive or anything like that?
There is roughly a dozen that we tend to pay the most attention to. The best of those are usually the Perseids in mid-August every year. Mostly because it can generate up to 75 meteors an hour on average, but it produces a lot of fireballs, which is it's not a speck of dust. It's maybe a piece of grit or like a tiny piece of tiny pebble that comes through the atmosphere, produces a really bright meteor, and it produces the most of those fireball meteors of any other meteor shower that we have.
Now, is sort of everybody on Earth able to see those, obviously not at the same time, but in the same sort of time of year, or is this a little bit more location dependent?
Yeah, as long as you have a fairly moonless sky, the full moon can really spoil a meteor shower just because of the extra light that it adds to the sky. But if you can have a fairly moonless sky at that time, it's just a matter of you just wait for the radiant, as they call it, the point in the sky where the meteors all seem to originate from, rises for your location, and it basically just follows the curve, the rotation of the Earth.
Right.
So it will start a little bit earlier for us here in Ontario, but over in BC they'll just have to wait 3 or 4 hours for it to rise for them, and then they can see it. Now another one is the Geminid meteor shower in mid-December.
Yes.
Now this one comes from a really weird object. It's actually an asteroid, or they actually call it a rock comet, called 3200 Phaethon.
They're just trying to confuse us.
Yeah, exactly. This is what they think may have been a larger icy comet in the past.
Okay.
And then after repeated tourneys around the sun again and again and again, it lost all of that ice. It just got evaporated off the surface. And so now it's just a giant asteroid flying on a comet-like orbit. And it just has a rocky surface. So all they're getting off of it right now is they're sensing dust and maybe some like sodium molecules, but not ice. But we still get this fabulous meteor shower every year, multicolored meteor shower for that matter, every December, which is one of the best ones that we ever see. And then there's the quadrantids in early January, which are from another failed comet, like a comet that has lost all of its ice.
Okay.
But it's a very, very short period of time that you can see it. Like it's over a couple of hours during that night, whereas it's all night long for the Geminids and the Perseids. But those are the 3 that we tend to concentrate on.
Okay.
Other than that, there's 2 in the spring that we watch, the Lyrids and the Eta Aquariids. There's a couple more in the summer. Most of them are in the fall. It's pretty much in the fall from September to December. There's never a period of time where at least one meteor shower isn't going on.
Oh, interesting.
So there's always a chance to look up and see meteors happening.
So the fall is sort of the best time to be looking up.
Exactly.
All right, in our preparation for this segment, we talked a little bit about interstellar comets. People hear the word interstellar.
Yeah.
They probably think of Sandra Bullock, George Clooney.
Right.
But there's actually sort of a tie to another Hollywood movie that was maybe a little bit ahead of its time.
Yeah. Back in like 1998, Armageddon came out, and it was a disaster movie about a giant meteor or a giant asteroid that was going to slam into Earth, and they saved the planet at the last very moment,
of course,
that they could. Yay us! But it was the origin of that object coming in to hit us was what they called a rogue comet at the time.
Right.
But that is really what an interstellar comet is. It's a comet that has been flung out of its solar system, that it's all on its own. And we've actually seen one of these for real now.
Okay.
We had Oumuamua, which is the weird, it was probably an asteroid, but it had a really weird shape to it, like almost like elongated flat shape to it that caused a lot of speculation. Like, could it have been an alien probe with a solar sail or something like that? But probably a natural object, just went through some sort of weird origin, broke off some object on its way here. But after that, there was also actually an interstellar comet that they found. It was going fast enough in its journey in towards the sun that there was no doubt that it would have come from outside our solar system. And then it did a little jink around our sun, and it zipped out of our solar system, and it's going to be gone, and we'll never see it again now. And we will probably, now that we're on the lookout for these things, we'll probably see more of them.
Right.
But yeah, Armageddon that's like 25 years ahead of its time, where it came up with this idea of a rogue comet, which I guess really wasn't something new at the time, but using it as their impetus for this disaster movie. At the time, they were way ahead of their time as far as.
So we should be paying attention to, science fiction movies now, projecting 25 years ahead, maybe a little bit about The Martian. We'll talk a little bit more about Mars
there you go,
another time on Out of This World. But okay, so let's sort of tie in interstellar comets or anything like that to what's the forecast for something large out in the solar system coming towards Earth, near Earth, posing any sort of threat to Earth?
Right. So there have been a lot of scares. We've had a lot of scares with these sort of things. There's a few asteroids that had come pretty close to Earth. There's one called Apophis that is rather famous. When they first detected this one, it looked like there was a decent chance that it might. I mean, when they talk about these percentages and chances, they're talking like 2%, a 2% chance that it would hit us. So there's a 98% chance that it wouldn't. But the focus is, well, that 2% is high enough. It's high enough that we really need to pay attention to it. So they took more readings of it and found, we're safe from that. And then they would be like, okay, well, it's still coming close to us. It's going to be, in 2029, it'll be 31,000 kilometers away from the surface of Earth, which is inside the orbit of the geosynchronous weather satellites that we use here at the Weather Network to give us their weather reports. So pretty close. Yeah. And it's big. So if this one were to hit Earth, it wouldn't be a world killer, but it would do massive damage to wherever it hit on our planet. So
when this passes 2029, is that something we're going to be very easily seen from us looking up?
Yeah, for anybody on the night side of the planet at that time, which I think is mostly Africa and Asia.
Okay.
They will be able to look up and maybe see this go by. Right. If they have nice dark skies to look up, then use binoculars. But we're going to have satellites watching this. We're going to have telescopes watching this as it goes by. We're also having a spacecraft chase it. The OSIRIS-REx spacecraft that visited asteroid Bennu and took a sample and brought it back here. Once it dropped off its little cargo pod, it took off again back into the solar system, and it will catch up to Apophis just after it leaves Earth's vicinity. Okay. So we'll sort of see the spacecraft whiz by us, give a little wave as it goes, and then it will follow Apophis to find out how much Earth's gravity diverted that asteroid's path. Right. To then give us a much better, clearer indication of whether it's going to be a threat in the future, because there are chances it does come fairly close to Earth, not on a regular basis, but at least several times into the future. But as far as we know now, of the 1.2, 1.3 million asteroids we know about, there are no actual threats to Earth for at least the next century.
All right, so we could breathe a sigh of relief.
Say something whizzes right by us and we know 3 years from now it's going to come back around and hit us, then we can build a spacecraft and send it out to that asteroid and smash it into it to change its course. And we've already done this. Things we don't know about.
Of course.
So interstellar object. Yeah. Those, we didn't even really have them on our radar back a few years, but now it's more interesting. But could we see something like that? How far away could we see it coming in towards us? Right. That's definitely something we need to watch out for. And there are things like the asteroid that blew up over Chelyabinsk, Russia in 2015. That one came at us from the direction of the sun. So we had no indication that it was going to be, we didn't know of its existence before that due to its orbit. But if there are other ones out there like that are going to come at us from the direction of the sun, we can't point our telescopes in that direction to get a view of these asteroids because they'll burn the telescopes out, right? Okay. The sun will burn them out. So basically what we need are maybe telescopes in Venus's orbit. Right. So that they can look outward from there towards Earth's orbit and see these objects as they whiz by that satellite. And they have ideas for how they can do this. It's just a matter of implementing it.
Right.
Because we need that extra view to protect ourselves, really. And if we detect something is going to come towards us, as long as we have enough time to deal with it, we do have methods, at least on the books, and we have one successful test mission to divert these asteroids so that we can maybe save ourselves from
so
these objects.
That's always the solution. It's,
Right.
you know, if something's coming towards us, we fly out to it,
Right.
or we can knock it off course, or
Right.
we can blow it up. Or,
Right.
So is that real? Like how realistic is that? Has that,
Right,
has
right.
that been done before? Has that been studied before?
Yeah. So I mean, yeah, the trope is kind of like send up nuclear weapons and
course.
blow it out of the sky. And
Yeah.
for some things that might have some application, we probably won't want to do that in most cases, because then you just create a whole bunch of smaller debris that could cause damage over a much wider area. But you know, necessity might require it at some point. But there are other ways. If we have enough lead time, like say something whizzes right by us and we know 3 years from now it's going to come back around and hit us, then we can build a spacecraft and send it out to that asteroid and smash it into it to change its course. And we've already done this.
Right.
It was called DART.
Yeah. Let's talk a little bit more about that.
Yeah. So in 2022, September, I mean, it launched a year before that. They sent this spacecraft DART, and it's the double asteroid redirection test, because they sent it out to these two asteroids. One is Didymos, which is the main parent body, the larger one, and Dimorphos, which is this little asteroid moon that orbits around it. And they targeted Dimorphos because they didn't want to target the larger asteroid. They don't want to actually divert its path around the sun, because then you're possibly creating a danger that might come back and kick us in the butt later on. Right. So they want to do it where they hit Dimorphos and watch the pair of them to see how their orbit and relationship changes. And they successfully did it. They set the spacecraft at it and said, you use your sensors to track this thing, go in at maximum velocity, smash into this asteroid, and then we'll see what happens. It went off perfectly. And they did divert the asteroid. It shortened up the orbit, so it now orbits faster around its parent body and at a closer orbit. So they successfully diverted it. So we have a practical test that said, yes, this is available for us as something to do if we detect something far enough in advance.
Right.
There are other ones. We can paint it with bright paint, with paintballs, basically. Send a spacecraft out there that's like a paintball gun. Pepper the one side of it with silvery paint or bright white paint, and let the sun's radiation do the work for us. Because every one of these asteroids has this effect, Zarkovsky effect, where sunlight heating up the one side of it will then radiate off the other side of it as it rotates, and this acts as like a tiny little thruster, a natural thruster.
Right.
But if you do that and you put bright white paint on one side of it, a lot more light gets reflected and a lot more light gets radiated away, and it's an even stronger thruster. And so if you can control that, you can actually divert these asteroids in a much more controlled fashion and move them on trajectories that are much more safer for us. You can use nuclear weapons, but this is more of a force thing. Like you're trying to not blow up the object, but force it with this, with the energy and the thrust force of the particles being thrown out by that nuclear explosion to push the asteroid away from us. So
didn't think I would learn about outer space paintballs
today. That was one of the most interesting ones I ever saw, and you could reuse the spacecraft. So if there were more than one asteroid that you knew was possibly a threat to us, you just hit the one, go to the next one, hit that one, go to the next one, hit that one.
It's a nice visual of a sort of almost like a crime fighting space machine or a security guard, I guess, to protect
They should give it a superhero name if they ever build it.
Exactly. I mean, Guardians of the Galaxy is already taken, so we have to find something a little bit more clever, I guess.
Exactly.
So how much, I guess, study or research is NASA and other agencies doing into all of this space matter that's near us. You mentioned OSIRIS-REx. That's one of the missions. What else are they doing, or what else are they looking into?
Well, right now, we actually have a sample of asteroid Bennu on Earth due to OSIRIS-REx. So this has been, part of it has been sequestered away in some vault somewhere for future scientists to study it with more advanced technology. Okay. But at the moment, the rest of it is being distributed to different countries that were involved in the mission. Canada is supposed to get some of that matter. So this can go to the researchers in these countries that they can actually like delve into this material and see how much water is in there. Are there organic molecules in it? Because we still have these questions about where did Earth's water come from? Where did we come from? How did life originate on this planet? Mm-hmm. And they have ideas for how the molecules came together, but the building blocks have already been found in these samples. So it may have been the asteroids that peppered Earth early on in Earth's formation that delivered those molecules simply from solar radiation and water mixing with minerals and so forth on the surfaces of these asteroids. And so being able to tell that, but also they want to know how strong are the materials in these objects for those defensive measures that we want to take towards them. So they're studying that. They want to know what is contained in these objects that may be of benefit to us in the future. Can we have asteroid mining? Can we send a spacecraft out to an asteroid and basically build another spacecraft from that asteroid, and then just let the little dusty fragments go on their way that we don't need, and sort of populate our Earth space fleet, I guess, of scientific vessels and further probes into the solar system and the galaxy from these materials.
All right. Yeah. So what we learned today, Armageddon, far ahead of its time.
Yeah.
For now, we are safe.
Yes.
And you can send paintballs into space as a way to combat asteroids or other matter hitting us. Always something fascinating when you look out of this world. We'll have a lot more in future episodes to come. Scott, thank you so much for joining us here today.
Yeah, it's been great.
It's very pretty out here.